Welcome back. Here's your warm-up if you want to give it a try. You should end up with, let's see, x squared equals -4, meaning that x equals plus or minus 2i. If you're confused about that, you want to go back to a couple sections ago whenever we introduced imaginary numbers. Okay, so this is 4.4b complex numbers. We want to be able to perform operations with complex numbers. So a complex number, remember that diagram that we looked at, right, where there's complex numbers, and then we're split into real and imaginary. Yes, and then the real numbers are split further into rational, irrational, and then rationals are split further into integers, whole numbers, natural numbers, right? So this is complex numbers, which is the outer, label. Okay, complex numbers. So they consist of a real and an imaginary part. They're written as a plus bi, where a is a real number, and then bi is an imaginary number. So a and b are going to be numbers, real numbers, right? So, but the I that's being multiplied, kind of, by that 3 makes it an imaginary number. So 5 is real. 3 is also real, but 3i is imaginary. So we have a real and an imaginary piece that makes this a complex number. So we can take sums and differences of complex numbers. We're just going to add and subtract their real parts and their imaginary parts separately. You can think about this kind of like the way that we combine like terms, right? So if we have this complex number, 12 minus 2i, and then this complex number, 16 plus 3i, we're going to combine their real parts and then their imaginary parts. Okay, so be careful, there's a minus sign right here, so we want to kind of treat this like we would with, regular combining like terms. We want to kind of distribute that negative. Minus 16 minus 3i, meaning we want to take this 12 and this 16. We want to take 12 minus 16, and we want to take negative 2i minus 3i, and we want to end up with negative 4 minus 5i, right? You don't have to rewrite it this way like I did in the real. This is why I did this, right? I took the real parts and I took the imaginary parts and I grouped them together. You don't have to do that if you just want to take 12 minus 16 and give me negative 4, and then you want to take negative 2 minus 3i and give me negative 5i. That is fine, okay? But I'm just trying to be consistent with that a plus bi notation. All right, so with adding, same idea, right? We can take 4 plus negative 6, and then we can take 4i plus 3i, and we can end up with negative 2 plus 7i. Pause the video, try this one. Keep in mind it's multiplication. All right, so hopefully you've dug around with this a little bit. We're just going to use FOIL. All right, we're just going to use FOIL because we are multiplying these together. So we're going to take our first times our first. 4 times 4 gives me 16. Outer, 4 times a negative 3i will give us a negative 12i. Inner will give us plus 12i. And the last will give us negative 9i squared. Okay, and so we're not quite done yet. We can clean up and combine some like terms. Okay, so I have 16, negative 12i plus 12i is actually going to become 0i, so those are going to disappear. All right, and then this negative 9i squared, remember that I squared is equal to negative 1, so we can rewrite this as negative 9 times negative 1, which will turn it into 16 plus 9, giving us 25. So when we multiply two imaginary numbers together, sometimes we will get a real number. Sometimes. All right, so pay attention to this. This is called, this is the idea of a complex conjugate, which we're going to come back to in just a second. All right, complex conjugate. Complex conjugates multiply together to give you a real number. Pause the video, try this one. All right, so let's use FOIL. 1 times 2 gives us 2. 1 times 5i gives us 5i. Negative 3i times 2 gives us minus 6i. and then we end up with negative 15i squared here. So let's combine these like terms, right? We have 2, and then 5i minus 6i gives us minus I. And then we'll be super careful with our signs here. We have minus 15 times negative 1, which will then end up being 2 minus I plus 15. So we can combine 2 plus 15 to give us 17. Excuse me. I don't know what I'm doing. 17 minus I. All right. And so it's pretty common notation. It's standard form of a complex number to write it in A plus BI format, even though your brain wants to tell you that I is a variable, you should write it first, BI plus A. That's what we're used to seeing with like a variable like X, right? We're used to seeing X first. But with complex numbers, we usually put the imaginary part second. It doesn't really matter that much at this point in your math careers, but at some point you may encounter an instructor who's more strict about it. All right, so this idea of dividing, we have to remember when we're dividing that I is a square root. All right, and so because of that, we do not want square roots in denominators. It's considered improper form. All right, so what we have to do is rationalize the denominators. That's just like that's a mathematician thing. People in the math world don't like to see 1 over the square root of 3. They don't like that in the denominator. It makes them uncomfortable. So what we have to do is multiply by the square root of 3 over itself, because this is really just multiplying by 1, right? We're not changing the value of our original expression. We're just rewriting it. So then we end up with 1 times square root of 3 on the top. And then square root of 3 times itself will give us a rational number in the bottom that's not a, doesn't have a radical, right? So applying that information to 5 over 3i, what we want to do is just multiply times I over I. All right, so we'll end up with 5i over 3i squared, meaning 5i over 3 times negative 1, which gives us negative 5i over 3. Right? That's all we got to do, multiply by I over I. Try this one. All right, so we're going to multiply by I over I, which gives us 2i over I squared, which is really 2i over negative 1, which is really just negative 2i. And so now we're going to run into a situation where we have addition or subtraction in the denominator, and so it's not as straightforward, right? When we are in a situation like this, we're going to multiply by the complex conjugate over itself, okay? And so 3 plus I, if I change to 3 minus I, then when I multiply them together, I'm going to get a real number, all right? And so because that's what I'm doing in the denominator, that's what I want to do in the numerator as well. This is like that example back here that we saw. See how 4 plus 3i and 4 minus 3i, they're the same, 4 and 4, 3i, 3i, but it's plus and minus. When that happens, it causes a situation where your middle term cancels out, your imaginary terms cancel, so you're just left with something that's real, right? So it's kind of a trick to help us out with these types of problems, okay? So be careful here, right? We're taking a minus 8, not a, 8 minus 4i times 3 minus I, and then we're taking 3 plus I times 3 minus I. So we got to use, we're using FOIL on both, right, the numerator and the denominator. So 8 times 3 will give us 24, minus 8i, minus 12i, plus 4i squared. Write this out just to be careful with your signs. And then taking a look at our denominator, 3 times 3 will give us 9, minus 3i, plus 3i, minus I squared. And then now we can clean up where we're able to, cancel some stuff out. Okay, numerator turns into 24 minus 20i plus, and this 4i squared is really like 4 times negative 1, so it's going to become negative 4. Right, and then we're dividing by 9, and then these 3i's are going to cancel each other out, right? Minus 3i plus 3i. So we're left with this minus I squared, which is really like minus negative 1. So our denominator turns into 9 plus 1. Almost done. Just a little bit of cleaning up left to do. Numerator turns into 20 minus 20i over 10. And then just for the sake of being as fully simplified as possible, let's factor out a 10 from the top. 10 times 2 minus 2i divided by 10. Those 10s will cancel, and we're left with 2 minus 2i. So our final solution is a complex number. Pause the video, give this a try. All right, so your complex conjugate would be 5 plus 2i. So our numerator is going to be more straightforward, right? We're just going to distribute this 3. So we'll end up with 15 plus 6i. And our denominator will turn into 25 plus 10i minus 10i minus 4i squared. Okay. Excuse me. 15 plus 6i over 25 minus 4 times negative 1 will give us 25 plus 4, which will be 29. So that's that. Take some time, sit with it. Let me know what questions you have.